Hello everyone, this is my next video on the topic transformer. In this video, I am going to discuss the concepts of autotransformer. I hope all of you have visited your electrical lab. Whenever you are performing any practical related with AC supply, most of the time you are using autotransformer. I don't think that any one of you are not aware about the autotransformer. Autotransformer is a device which is used to give you supply by increasing it gradually. It means whenever you are connecting any AC machine, you are not giving supply in a full swing. You always try to give supply gradually. And for this purpose, whenever we are performing AC machine related practicals, we are using in almost all the cases auto transformer as a medium through which we can give supply from 0 to the maximum value in steps. So in this video, we are going to discuss the concept of auto transformer. So here you see this figure shows an auto transformer. Here you will see the single binding is used for both the circuit, primary as well as secondary. So we can say that in auto transformer, one binding is used as primary as well as secondary binding. In two binding transformer, we use two bindings for primary and secondary purpose, but here we are using only one binding. So when we are using the one binding, then this one binding will be used for providing both the operations, conduction as well as induction. What does it mean? It means when we are giving supply here, then from the supply, we will ultimately get the supply at the load terminal. Power is transferring from this side to this side by two principles. One principle which we call conduction and another principle of in which transformer acts is induction principle, right? So in auto transformer, power will move from input to output terminal by both the actions, conduction as well as induction. Now from the transformer action, we know this relation V2 upon V1 is N2 upon N1 is I1 upon I2 equals to K, say. Now the first point which may come in our mind that if power is reaching to the load terminal by two methods, then we should know how much power will reach by conduction method and how much power will reach by induction method. So this we can derive from here. As you know from this figure that power at input terminal is V1 I1. You see here the power at input terminal is V1 I1. Power at output terminal is V2 I2. Now we are assuming this whole winding into two parts. One full winding AB, one part AC and one part BC. Here, if number of turns for this whole winding is capital N1 and for this less winding, this CB part is N2, then you see the number of turns from A to C will be N1 minus N2. And this point C is a movable point. So when I am increasing or decreasing this point, I am changing the number of turns in secondary side, and as a result, by this formula, the output terminal voltage will change. And this is the beauty of this auto transformer, that by changing the position of this point, we can change the voltage at the load terminal. You see here the total voltage is V1 and this voltage is V2. Obviously the rest voltage AC in AC terminals will be V1 minus V2. Also you see current I1 is coming from this side, means I1 is coming from supply, and I2 is going towards load. So this means I1, I2 will go here. So I1 minus I2 come down. If I1 minus I2 current comes down, we can also say that I2 minus I1 current goes up. The same thing, only the convention of the sign, right? So by this knowledge, we write these equations. Power from the input terminal of autotransformer is V1 I1. Power at the load terminal is V2 I2. Power at terminal AC. Power at terminal AC. You see here, what will be the power? V1 minus V2 into I1. This voltage is V1 minus V2. Current is I1. Right. Power at terminal CB. Power at terminal CB. What is the voltage here? V2 and current is I2 minus I1. So these are some powers. Now I am interested to know the ratio of power transferred from transformer action to the power at the load terminal. So you see the power transferred from the transformer action is I2 minus I1 times V2 because this is the current in this binding and this is the voltage across this binding. So by transformer action we will get at the load I2 minus I1 into V2 while total power at load terminal is V2 I2. So when I am dividing here and solving by taking I2 common, y1 minus I2 will come here which is equals to K. So I will get 1 minus K. Now you see the total power at the load terminal is V2 I2. Power from the transformer action is I2 minus I1 into V2. So rest power will be the power by the conduction method. So power conducted directly will be power at load terminal minus power by the transformer action. So this will be the power due to the conduction principle KV2I2. Hence, we can conclude here by equation this one and this one that the power at load terminal by transformer action will be V2I2 may be shifted here. So 1 minus K times power output, and for conduction principle K times V2I2 means power K times sorry K times power output. So you can see here that if we know the turn ratio, by this turn ratio we can calculate how much power will reach to the load terminal by transformer action and how much power will reach by the conduction method. Okay. Now the second point which may come in our mind, that what is the advantage of using autotransformer? So the first thing, if autotransformer is using only a single winding, obviously it must save some copper. If copper will save, ultimately the binding size will be less, and if the size will be less, the device will be compact and easy to use, and the cost will also be less. So how can we calculate this term, the conductor saving in autotransformer? See here, as we know that conductor size will depend on the current carrying capacity of the binding and its number of turns, right? In other words, conductor size will be directly proportional to the MMF in the binding. In previous classes, I have told you that MMF is defined as number of turns into current. So if we have more number of turns, then obviously the binding will carry more MMF, magnetomotive force, right? So this means, in other words, you see MMF equals to Ni, means the conductor size will depend on the total value of MMF. In two binding transformer, we have two bindings, N1 primary side, N2 secondary side. So the conductor size in conventional two binding transformer will be N1I1 primary side, N2I2 secondary side. So N1I1 plus N2I2. If I use this relation given here, so I can simply find out that N1I1 is equals to N2I2. So I'm writing this whole term as either 2N1I1 or 2N2I2. Anything I can write. In autotransformer, you know that we have only one binding, which may be considered to be splitted into part AC and part CB. So you see here, in part AC, number of turns are N1 minus N2, current is I1. In part CB, number of turn is N2, current is I2 minus I1. So what will be the conductor size? N1 I1, the conductor size will be proportional to N1 minus I1 into I1 plus N2 into I2 minus I1. So here you see the total conductor size in autotransformer is proportional to this term. Now you solve this expression. When you will solve, and after solving you will get this relation, and if you use again the relation given here on solving, you will get 2N2I2 1 minus K. So this is the conductor size in autotransformer. This is the conductor size in two winding transformer. So when you divide these two expressions, the weight of conductor in autotransformer divided by weight of conductor in two winding transformer will comes out to be 1 minus K. And hence from this expression you can calculate how much copper we are saving in autotransformer. So if I want to calculate my saving for copper, then it will be equal to weight in two winding transformer minus weight in autotransformer. Now put the value of weight in autotransformer from this expression. So 1 minus K times weight in two winding transformer. Now you will solve, you will get K times weight in two winding transformer. So you can see here that in autotransformer, the saving can be calculated by the formula K times weight in two winding transformer. So if the value of K is 2, then our saving will be double, means 50% size copper we will save in auto transformer. So this is the beauty of auto transformer, that it will reduce the size of conductor, and therefore due to this reduction in the size, obviously our device will be compact, and naturally its cost will also decrease. Here you see again advantage of auto transformer. Number one, auto transformer is smaller in size and cheaper, as I told you earlier just now. An auto transformer has higher efficiency than two binding transformer. This is because of less ohmic and core loss due to reduction of transformer material. Obviously, if you are using only single binding, then you are using less resistance, and if your resistance is less, your one binding is at same place, so there will be leakage value will be very less, and since the leakage value is very less, obviously the core loss reduction will be more, and you can say that your efficiency will increase. Auto transformer has better voltage regulation in resistance, and reactance of the single winding is less. Okay, because the value of resistance and reactance is less, so voltage regulation will also be better in auto transformer. Now you see the disadvantage of the auto transformer. Secondary binding is not insulated from the primary binding. You see here that both the bindings are same, so there is no insulation between them, and if there is no insulation between them, it may be dangerous sometime.